Okay, let's unpack this. We are diving deep today into optimizing JavaScript execution.
Yeah.
If you've ever felt that frustration,
Yeah.
a slow web page, buttons that lag, maybe choppy animations, well, that's the core problem we're tackling. Slow or unresponsive JavaScript code, just holding things back.
Absolutely. And performance, it isn't just like a nice extra feature. It really hits the user experience hard.
Right.
So our mission here really is to pull out some key strategies, ways to help you write faster, more efficient code. Think of it like building up a mental toolkit.
Exactly. And optimization might sound a bit intimidating, like it's only for gurus.
Yeah, sometimes it feels that way.
But it's actually fundamental. It doesn't matter if you're just starting or you've been coding for ages. Understanding why your code runs like it does and how to smooth it out, that's just crucial.
Couldn't agree more. So where do we start? I think some of the biggest wins often come from the basics, right?
Yeah.
Algorithmic efficiency, data structures.
Right. That brings us to things like big O notation.
Yeah, exactly.
Which is basically, a way to describe how the time or maybe the memory your code uses, how it scales up when you throw more data at it.
And picking, the right tool for the specific job is just paramount here. Like using data structures such as a set or a map when you need to look things up. That can give you almost instant access. We call that O1 time complexity, roughly, which is worlds faster than, say, digging through a huge array. That often means checking every single item, ON complexity, where N is your number of items.
So if you find yourself constantly checking, is this thing in my list? Maybe reach for a set instead of an array, especially if that list gets big.
Yeah.
That choice alone can make a huge performance difference.
It really can. A fundamental choice, huge impact. And building on that idea of fundamentals, another key thing is just reducing unnecessary work.
Okay. Like when you're working with the web page itself, the DOM.
Exactly, the document object model. A really common pitfall is, say, repeatedly asking the browser to find the same element or read its properties inside a loop.
Right, when the information isn't even changing within that loop.
Precisely. And it's good to understand why that's costly. Every DOM interaction, it could trigger the browser to recalculate layouts or repaint the screen, which takes time. So doing that hundreds, maybe thousands of times inside a loop, it's just redundant work, and it blocks up the main JavaScript thread.
And that's the thread that needs to stay free to handle user clicks and keep things responsive, yeah.
That's the one. So the tip is simple, but really powerful. If you need that element reference or value multiple times in a loop, grab it once before the loop starts.
Makes sense. Cache it, basically.
Yeah, and sort of extending that idea, avoiding unnecessary work, we also see techniques for managing how often code runs when events fire really frequently.
Oh, like window resizing or scrolling. You mean debouncing and throttling?
Exactly. Debouncing is great for things like, say, a search input. You only run the search function after the user has actually stopped typing for a moment.
Okay, so it waits for a pause.
Right. And throttling. That ensures your function runs, but not too often, at most once every, say, 200 milliseconds during a scroll. It stops the handler from just overwhelming the browser.
Gotcha. So both are about preventing your code from just hammering the browser constantly during those rapid-fire events. Keep that main thread clear.
Keep it clear. Keep the UI responsive. Yeah. If we kind of pull back and look at the bigger picture, these techniques, sufficient algorithms, right, data structures, minimizing DOM hits, managing event handlers, they're all really about doing less work or doing it smarter to stop your code becoming the bottleneck.
And I guess for those really heavy tasks you just can't avoid, like complex math or processing tons of data, there are things like web workers, right?
Yeah.
To offload work.
Yeah, that's a more advanced topic, but definitely relevant. Running code on a separate background thread so it doesn't freeze the main interface, it just highlights that optimization isn't usually about finding one magic fix. It's more about developing this awareness, across different parts of your code, from the core logic right through to how it interacts with the browser.
Exactly. So you've now got a feel for several powerful strategies, from making smarter data choices to being mindful of that repetitive work and controlling how events run.
And what's really interesting, I think, is that becoming a coder who writes performant code, it's less about memorizing every single trick under the sun.
Yeah.
It's more about cultivating this mindset, always looking for chances to make your code run smoother, faster, and just better for the person actually using it.
That's a fantastic thought to leave everyone with. So as you think about the code you might be working on right now or maybe later today, What specific area could you potentially look at optimizing using some of these ideas we've talked about?